Good morning.
Good morning, sir.
Good morning, sir.
Sahana, ಇನ್ಯಾರು ಬಂದ್ರಿ?
Sir,
ಸಹನಾ ಆದ್ಮೇಲೆ
Nisarga,
ನಿಸರ್ಗ, ಆಮೇಲೆ
Priyanka.
ಪ್ರಿಯಾಂಕ, ಆಮೇಲೆ
ಅಷ್ಟೇ ಸರ್ ಬಂದಿರೋದು.
ಓಕೆ. 2 ನಿಮಿಷ ನೋಡೋಣ, ಎಲ್ಲ ಬರ್ಲಿ.
ಸರ್.
ಏನಾಯ್ತು? ತಿಂಡಿ ಆಯ್ತಾ? ಕಾಫಿ ಆಯ್ತಾ?
ಆಯ್ತು ಸರ್.
ಎಲ್ಲ ಮನೇಲೇ ಇದ್ದೀರಾ, ಎಲ್ಲಿದ್ದೀರಾ?
ಮನೆಯಲ್ಲೇ ಇರೋದು ಸರ್.
ಓಕೆ ಓಕೆ, ವೆರಿ ಗುಡ್. ಹೆಂಗಾಯ್ತು ಎಕ್ಸಾಮ್ಸ್ ಇತ್ತು ಯಾರ್ದಾರು?
ಸರ್ ನಂದಿದೆ 18th ಇದೆ ಸರ್.
18th ಇದೆಯಾ? ಓಕೆ. ಓಕೆ. ಆಮೇಲೆ ಇನ್ಯಾರ್ದಿದೆ? ಅಷ್ಟೇನಾ?
ಸುಷ್ಮನ್ ನಿನ್ನೆ ಆಗಿರ್ಬೇಕು ಅನ್ಸುತ್ತೆ ಸರ್.
ಬಂದಿದ್ರು ಅವರು. ನಿಸರ್ಗ ಮತ್ತೆ ಸುಷ್ಮಾ ಬಂದಿದ್ರು. ಸಿಗ್ನಲ್ಸ್ ಇತ್ತು ಅನ್ಸುತ್ತೆ.
ಸರ್.
ಓಕೆ, ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಬರೋರೆಲ್ಲ ಬರಲಿ. ಓಕೆ, ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಇನ್ ಲಾಸ್ಟ್ ಟೈಮ್ ಐ ಹ್ಯಾಂಡಲ್ಡ್ DIDSP, that is digital signal processing. For this semester, for 7th semester, I am handling digital image processing, DIP, and subject code is 17, is 72. Okay. The objectives of this course is: are you able to see the screen, right? Is this visible?
Yes, sir.
Okay. Yeah, the objectives are to understand the fundamentals of digital image processing. What is the meaning of digital image processing? What exactly it refers? What is image? What is digital? And what is the meaning of processing? Those things we are going to understand. These are the fundamentals of digital image processing. Then understand the image transforms used in digital image processing. How exactly the images are transformed to one domain to another time, that is a time domain to frequency domain and vice versa. And what are the transformation that are used to convert the image, digital image, that we are going to learn. Then understanding the image enhancement techniques used in digital image processing. What are the image enhancement techniques? What exactly the meaning of enhancement, and what are the algorithms that are used to enhance an image, and techniques which are used in digital image processing. Then you are going to learn about the image restoration techniques. What is the meaning of restoration? What are the techniques that are used to restore an image? Enhancement means enhancing the brightness, contrast, illumination, okay, size, cropping, then etc., rotating, shifting, etc. And image restoration means restoring the image, that is we call it as what? Denoising. Okay, denoising image or restoration techniques that are used to get back the image. Okay, we call it as what? Image restoration. And the techniques and the methods used in image processing. Then we have morphological operations and segmentation used in digital image processing. Morphological operations means cropping the image and labeling the image, labeling the parts, converting from 1D to 2D, 2D to 3D, and labeling the parts, object recognition, background recognition, contrast recognition, brightness recognition. Everything comes under morphological operations. Morphology means we call it as what? Physical operations. Some physical operations we are going to operate on the image. And we have segmentation. What is the meaning of segmentation? How exactly segmentation is used? What is the meaning of segmentation? What is the techniques that are used to segment an image? Segment an image. Then we have these are about the course objectives of the in digital image processing. Then we have module 1. In module 1 we have digital image fundamentals. What are the fundamental techniques that are used in image processing? We have what is digital image processing, what exactly the meaning of digital image processing. Then origins of digital image processing, that is how exactly the digital images are extracted or acquired. Okay, what are the origins? Example is by digital camera. Okay, by capturing image from a digital camera we can get the image. Okay, then we have examples of a field that use DIP, that is applications of digital image processing. What are the in which fields the digital image processing operations are used? Fundamental steps in digital image processing. What are the fundamental steps, basic steps, or primary steps? We call it as what? Pre-processing operation, post-processing operation, those things. Okay, we are going to learn. Then components of image processing systems. Okay, some components were there. Okay, means some block diagrams were there. Fundamental steps involves acquiring the image, segmentation, restoration, then morphological operations, color image processing, knowledge base, etc. And the components are some components were there. We are going to learn. Then elements of visual perception, how exactly the colors can be visualized, how exactly the picture is formed in retina. Okay, we know retina, right? In retina, how exactly the picture is going to form. Then we have image sensing and acquisition, that is how exactly the images are sensed by an camera and how it is acquired. Okay, we call it as what? Using some sensors, image sensors, we are going to sense the images. Okay, then we have image sampling and quantization, that is already you know what is this visible and audible?
Yes, sir.
Shall I continue?
Yes, sir. Yes, sir.
Yes, sir.
We're getting or not?
Getting.
Yes, sir.
Yeah. Yeah, then we have image sampling and quantization, that is how to sample an image. You know already sampling and quantization, but how exactly this sampling and quantization is applied for an image. Okay, we are going to learn. Okay, then some basic relationship between the pixels, linear and non-linear operations. What is the meaning of pixel? Pixels or pels, we call it as what? Picture element. All these are same thing. What is the basic relation of a pixel? And then we have a linear and non-linear operations. Okay, what exactly the linear operation is and what exactly the non-linear operation. These are some algorithms were there, some operators were there. We call it as what? Sobel operator and prefix operator, then Fourier operator, Laplace operator, those things were there. We were going to learn about these things. Okay, this is about module 1. In module 1 you are going to learn about the basics of image processing and the origin, how exactly images are acquired, the fundamental steps, the components, and how exactly the images are quantized and sampled, and some basic relation of the pixels. Okay, this is about module 1. In module 2 we have a spatial domain. Spatial domain means time domain. Spatial means time. In time domain, how exactly the images are reflected, how exactly the images are represented. We have some basic intensity transformation functions. Okay, that is some functions were there, log function, then trigonometric function, sine, cos functions, etc. We are going to learn about this intensity transformation functions. Then we have histogram processing. Histogram means if I consider some image, the image may consist of different brightness of for different colors. For example, yellow contains more brightness, whereas black contains less brightness. Okay, depending on that, we are going to divide the intensity of an image. Okay, that division or decomposition of we call it as what? The intensity is done by the histogram processing. Okay, completely you are going to learn. No worry. Just I am briefing the what topics. That's it. Histogram already you know. Histogram means it gives different graphs, right? Different intensity graphs. Okay. Then fundamentals of spatial filtering, that is time domain filtering, smoothing spatial filters, that is a smoothing operation. We have sharpening spatial filters, smoothing and sharpening spatial filters. These two are just simple, you know already. That is a DFT and DTFT, that is discrete Fourier transforms, in time domain. Okay, Fourier transforms and discrete Fourier transforms and Fourier series. Okay, so some formulas were there. That's it. Yeah, then we have after spatial domain we have frequency domain. In frequency domain, it is a preliminary concepts were there. That is as I said, it is discrete Fourier transforms of two variables, properties of 2D DFT, filtering in frequency domain, image smoothing and image sharpening using frequency domain filters and selective filters. Okay, these are just about already you studied in DSP. Those things will come here. That is a 2D DFT and DFT and DFS. Yeah, this is about module 2. In module 2, how exactly the images are represented in spatial domain and in frequency domain we are going to learn. Okay. Then we have restoration. In module 3, restoration is there. In restoration, we have some noise models. Okay. Already we know in each and every digital data, or it may be a physical data, we have some noises. Okay. Those noises in image we call it as what? Some for example, if you take some picture, if you shake the camera, it becomes what? Some blur image you will get, right? Okay. That blur image we call it as what? It's a noise. Okay. Those noises can be removed. In some mobiles it is there. Okay. In some modern mobiles, if you take the image, if you shake the camera, the blur will automatically recover. Okay. In maybe it is in Sony Ericsson camera. Okay. It will auto correct the image. Okay. Those are noise models were there. We call it as what? Gaussian noise and another white noise. So many noises were there. Thus, those we are going to learn in restoration. And restoration in the presence of noise only using spatial filters, frequency domain filtering, linear, position invariant degradations. All these things are with respect to noise only. Okay, and estimating the degradation function, inverse filtering, minimum mean square error, that is MESE error. Then we have a linear filter, then constrained least square filtering. Okay, filtering is done to remove the noise. These are the some of the filters that are used to remove the noises in the image. Okay, first we are going to learn about the noises in the image. Then you are applying some filters to remove the noise. Okay, the entire process we call it as what? Restoration. That is, I am restoring back the image from by removing the noise and enhancing the image. This is about your module 3. Yeah, next comes module 4. In module 4 we have color image processing. Okay, in images there are two types over there. One image we call it as what? Grayscale image. Second image we call it as what? Color image. Grayscale image means, gray means it is a combination of the black and white color. Okay, for 0000 we call it as what? It's a complete black, and 111 we call it as what? Complete white. Okay, in between 000 and 111 we have 001, 010, 011, 100, 101. Those colors we call it as what? Grayscale colors. It's a shade of colors. Okay, it's a shade of black and white. Okay, until this third chapter we are going to learn about the grayscale images. In chapter 4 in module 4 we are going to learn about the color image processing. Then what is color image processing? We have three basic colors, that is R, G and B, that is red, green and blue. Okay, these are the fundamental colors. Here color fundamentals, the fundamentals colors are what? RGB. Using this RGB you are going to model the colors. We call it as what? Color models. Okay, that is by combining of RG and BR etc, you are going to get other colors, that is yellow, white, black, magenta. So many colors will come. Okay, we will see those modules. Those module 3 modules were there. And pseudo color image processing. Pseudo color means it's a mixture of random color. Okay, so many colors, the mixture of so many colors we call it as what? The pseudo color. Okay, what about the pseudo color? How exactly it is formed? Everything we're going to learn. For example, very simple example is pseudo color means. Okay, if you take the picture of a galaxy, you can see the galaxy picture, right? Okay, galaxy are complete. We call it as what? The infinite sky. Okay, you will get so many colors in that. Okay, that is the best example of pseudo color. Okay, it's a random mixture of colors. Okay, then we have wavelets. What is the meaning of wavelets? What exactly wavelet will do? Background, the multi-resolution expansions. Okay, this is the about wavelets. Wavelets are the filters that are used to filter the image. Okay, then we have morphological image processing. As I said, morphological image processing means what? Just crop, cutting of the image, then extracting the object from an image, cropping the data, exactly will comes under, and labeling the picture comes under morphological processing. We have preliminaries of the morphological image processing. Erosion and dilation. Erosion and dilation is there. Opening and closing, hit and miss transforms, some basic morphological algorithms were there. Okay, This is about your color image processing and morphological image processing. This comes under module 4, and for this is for color image processing operations, color image. Then we have module 5, that is segmentation. What is the meaning of segmentation? The name itself suggests, tells that it's a, we are segmenting the image, that is we are dividing the image to certain small images. Okay, big image are converted to small images. That is point operation, line operation, edge detection, thresholding, region based segmentation, segmentation using morphological watersheds. What is the meaning of watersheds and all? We're going to learn. Okay, yeah. Then we have representation and description. How exactly the images are represented and described. That is representation, boundary descriptors, etc. Okay, this comes under module 5. Okay, these are the contents what you have in your digital image processing. Now we have some block diagrams, some explanations, some what problems, some derivations were there. Okay, it's a complete mixture of everything. Okay, and it is very important subject to learn for an electronics engineer. Okay, you can do all the programs using MATLAB. I will show some of the programs in MATLAB, no worry. Okay, we're going to learn about the complete image processing techniques in this subject. Okay, if anyone interested, you can do your project using image processing techniques, image processing algorithms, image processing methods. Okay, using MATLAB or Python tool. Okay, Python is the very best tool for image processing. Okay, nowadays they are using Python as a basic and main tool to do operations on digital image. Okay, other than that, we can use the MATLAB. MATLAB is the very primary tool, and some advanced tool is your Python. Okay, in both the languages, I can write the programs for an digital image. Okay, I can do n number of operations in an image by using an image, and you can write very good algorithms. Okay, you can do small projects, or you can do your main project also using image processing only. Okay, and these things are just we don't have any modules. Instead of that, we will get what, some what we call execution of the programs. That's it. Okay, yeah, this is about your subject contents. Okay, and textbook is Rafael Gonzalez. Gonzalez is available in your this one library. You can take this book. Okay, complete things will comes on under this one only. Okay, and another one book is there, Digital Image Processing, Jairaman. Okay, this is also a very good book, and we have fundamentals of image processing by AK Jain. Okay, this is the another book. This contains, this third book contains all your basic equations. Okay, if you want to see the equations, you go for this book. You want to see the concepts, you go for Jairaman, Digital Image Processing, and both all the data is contained in your digital image processing. That is textbook is Gonzalez. Gonzalez is a very good book to study. Okay, you can get this book in our department library or in main library. It is available. Okay, okay, this is about your contents. Any doubts?
No, sir.
Okay, for today, yeah, for today's class I will stop now. Okay, and I will continue in the next class. Okay, we'll see the basics of digital image fundamentals. Okay,
Sir.
yeah, tell me. Okay, is it clear?
Yes, sir.
Okay, see you in next class. Right.
Thank you, sir.